Right, welcome back. This is the last one of the functional skills level 2. I know I've put city and guilds there, but I've waited right till the end to say, well, this is okay for um, any exam board, open source, city and guilds. I don't know whether Edexcel, AQA still do them, but yeah, anyone you like. Right, it's also really good for getting you into a GCSE if you wanted to do this. Go through all these before you started the GCSE course, then good on you. Right, scatter diagrams. Scatter diagrams. Scatter all over the place, yeah? Um, right. Now, what scatter diagrams attempt to do is to find a correlation between two independent events. Now, what does this mean? Imagine um, everybody goes to school and some of them wear red hats. It would be an attempt to find, is there something in it that do people with red hats do better in their exams? A bit weird, but that's the sort of thing. Something so completely bizarre and so what you would think would be unrelated. Um, can you find a correlation between them? Say, in the big wide world, is there a correlation between poverty and crime or something like this? Yeah, poverty, the average income of a certain town, and crime, the crime figures of a certain town. Is there more crime when there is more poverty? This sort of thing. Now, what we do is we let's have a look at an example. So normally, because these are aimed at 16-year-olds, they will be geared around things that will be familiar to them. So we can have a maths exam and an English exam. Now, of course, the results that you get in English have got nothing to do with the results that you have in maths, and vice versa. But can we find a correlation to say that if you're better at maths, you're probably going to be better at English, or if you're better at maths, you're worse at English, this sort of thing. So they will give you a table of some results, and I'll put them in sort of numerical order, yeah. I'm just guessing some numbers. 65. Keep them at this. 70. Um, 80, 80, 90, and 80. Yeah. Right. So we've got 1, 2, 3, 4, 5, 6. So perhaps up here we would have the maths, and down here we'd have the. Let me come down a little bit. The English. And so this is the percentage people got, and the English percentage. And so we're going to, nice and easy, I'll just go 10, 20, 30. No, I won't. I think I can get my scale a bit better than that so that we can actually see what we're doing. Let's go up in twos. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And I wonder whether we could do the same for here. It's not going to fit, is it? So I'm going to have to go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 there. And these are going to be your coordinates. And use these coordinates to plot a point on the graph, the scatter graph. So 30 in maths, you get 35 in English. So 30 in maths, you get 35 in English there. 40 in maths, you get 30 in English. So 40 in maths, you get 30 in English, 50-50, 50-50 is there, 65-70, 65-70, 80-80, well that's a fairly easy one, 80-80, and 90 and 80, 90 and 80, there we go. So, normally when we do graphs, what we do is we have all our points and we go join them all up together like this. Yeah, that is wrong. We don't do that in a scatter graph. And what we do in a scatter graph is something called a line of best fit. So first of all, your first couple of points for this kind of question is to actually plot all the things on the graph. You may have to work out the scales for yourself, but definitely you will be plot all the things on the graph. And a line of best fit is a line such that it sort of goes through the middle of all of the plotted coordinates that you have. And this is like a sort of an average line that just wanders up through the middle, and that's called a line of best fit. Now, the line of best fit must stop at the end of the data. Yeah, you cannot predict above. That's a bit short actually, but don't matter. We've got the idea. You cannot predict above and below the data that you have. Now, a question on this would be if Sam scores, what can Sam score? 45 in maths. What would be the English score? And this is why you have to draw your line of best fit. So you've plotted all the coordinates, you've drawn a line of best fit, and now you're going to find out where 45 in maths is, and let's go from there. 45 in maths is there, and you go along until you get to the line. And then when you get there, you come down there and you read from the bottom, and that looks like 45 again. So we'll say 45 is the answer in English. Now, the reason why you do not go beyond the end of the data is because they might ask you a trick question. If Sam scored 20 in maths, what would be the English score? Now, 20 in maths, if we look down here, is beyond the end of the data range that we've got. We do not know what would happen down there, so you say you can't tell. So watch out for that, and the reason why it is beyond the data range. Okay, so that you might be asked to give the reason why. So if you've got a number that's beyond, say like somebody gets 100, you can't tell what they're going to get in English because it's beyond the data range at the other end. So you plot the coordinates, you look at what the question that you need to do, and you have to draw a line of best fit, which is an average line all the way up through the middle, and then you just go along till you get to your line and down. And don't worry about being, super accurate, because to a lesser or greater degree, everybody's line of best fit will be slightly different. So as we have 45 here, they would say anything will do between, say, 42 and 48 or something like this. Depends on where your line goes. So that is a scatter diagram, and we'd attempted to make a correlation between the maths and English, and you can see that all these sort of give you an uphill thing. Come back to that in a second because it's just one thing that I've thought of. If, say, somebody gets 70 in maths and only gets 20 in English, we would have a point up here, almost there, yeah? And that point is called an outlier. Don't know whether that's an outlier. Do I want to? I don't know how to spell that, but I'll call it an outlier. Whether it would be YER, I don't know. It's an outlier because it's sort of separated from all the main coordinate points. So yeah, it's like owl on its own. It's an outlier. Yeah, so it might ask you to ring round after you've plotted all the coordinates, ring round the outlier, and then do line of best fit, across, down, answer. Cross, down, can't tell beyond the data range. That's all there is to scatter diagrams. So we need to look at some questions. Right. So here's a pretty good example of a question. The table below shows some information about 10 flats available to rent, the number of rooms and the monthly rent. So what we're trying to do is have a correlation between the number of rooms and how much it costs. Do more rooms cost more money? Draw a scatter diagram for this information on the grid below. So we can go up to 9 rooms, so I'll have the rooms over here. Doesn't really matter which way round you do this. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And the money goes up to 950. So I'm going to go in hundreds. 1, 2, 3, 400, 500, 600, 700, 800, 900. Yeah, and this is the cost. Cost rent. Don't forget to label everything up. The costing rent in pounds. So now we've got all these coordinates that we can plot and see what it looks like. So 2 rooms is £300. 4 rooms is £450. Does take a long time to do these questions. 5 rooms is 500. 8 rooms is 750. 750. An 8-room flat, that's something else, isn't it? 5 rooms is 600. 5 rooms is 600. 4 rooms is 400. We've got them all over the place. 2 rooms is 350. 8 rooms is 900. Oh, that's an expensive one. 9 rooms is 950, even more money. 7 rooms is 800. 7 rooms is 800. So that's what that looks like. Yeah. Scatter. They've not asked us to draw a line up the middle yet. No. Add, oh, here we are. Add a line of best fit to your scatter diagram. So, I'll do it in different colours so we can see what we do. So, go from the more or less up through all the middle of these things. So you've got more or less the same above as below the line. Yeah, I'll do that. That's fine. Now, use your diagram to estimate the monthly rent you might expect to pay for a flat with 6 rooms. So, let's go for 6 rooms. And we'll go across to meet our line of best fit. And then come down to there. And I would think that, we'll call it £650. Yeah. So, again, there's a table. We plot the coordinates. We draw a line of best fit. And then we answer the question using that line. Now, the scatter diagram on the right shows the average temperature and total monthly rainfall. Okay, so temperature along the bottom, rainfall. Use the diagram to predict the average temperature when the total monthly rainfall is 45. So we need a line of best fit, don't we? We need a line of best fit going through there. Something, oh, it's going around the corner, but yeah, that'll do. So when the average rainfall is 45, which is there, I'll meet that one and come down and 4 degrees Celsius. Describe the relationship that is shown in the scatter diagram. Right, now we need to go back to work on what relationships are in correlation. Now, there are 3 main ones and 2 sub ones. So imagine this is our diagram, and as our scatter diagram is going like this, going like this, going like this. It goes up from left to right. Yeah, I suppose we can draw a line of best fit through the middle, yeah, something like that. Yeah. Now this is called a positive relationship. Now, if we have something like this, where it goes the other way, no prizes for guessing what this is. This is a negative relationship. And this one down here, and we cannot draw a line of best fit that goes all the way through this, so this is none. There is no correlation. Now, I've said there's the 3 main ones. We've got 2 sub ones, which is worth knowing, but I don't know whether it comes into functional skills or not, but we'll do it anyway. So we'll do this, and yeah, and this one. Now you can see that they're both positive, but these are a bit further apart. They're a bit more scattered than these ones. So this will be a strong positive, and this will be a weak positive. And exactly the same if we have a negative, where we've got all the little lines together here, like this. What colour am I doing that with? Red. Yeah, again, these are closer together, so this could be called a strong positive, and this could be called a weak, a strong negative, sorry, and this would be a weak negative. So I'm not sure whether you need to add these adjectives in, strong or weak, but definitely know positive and negative. The uphill ones are positive and downhill ones are negative. Everything always goes from left to right when you're doing graphs. Okay, and no correlations all over the place. So let's have a look at this question down here. Describe the relationship that is shown in the scattergram. And I'm just going to put, because they're quite close together, so I'm going to put that they are strong positive. All right, strong positive. So that's the end of that one worksheet. Thanks very much for watching, and something else will be coming up soon. So keep your eye on there, and you can always subscribe if you want to. I don't bother to ask. I just do this for fun. So I'll see you in the next thing.